I'm Surendra Byna from Lawrence Berkeley National Laboratory. I'm going to talk about a trillion particle simulation. Trillion particles are pretty large, more than the team size. So I don't have to explain a lot about or emphasize a lot about large data to this group of audience. So there are many applications that produce huge amounts of data, and these are all scientific application examples. And storing, analyzing, and visualizing large data are big challenges. And today I'm going to talk about one application that is a VPIC simulation. VPIC simulation is a plasma physics simulation. It is very scalable, and it runs on many supercomputers now. And recently we finished one run on a Hopper supercomputer at NERSC. It has 6,400 nodes and about 150,000 cores. The main thing we had to focus is we use Lustre parallel file system. This simulation uses 120,000 cores, and it uses 20,000 MPI processes, and each MPI process has six OpenMP threads. And the one thing I can note here is, particle data set per time step is about 30 terabytes to 40 terabytes, and there are 19,000 time steps in the whole simulation, and we collect only 11 time steps because we don't have that much memory, that much storage, and it costs up to about 400 terabytes. So as I mentioned, the challenges are: what is the scalable strategy for storing massive particle data set? And we can use in situ analysis, where if we know what analytics can be done a priori, where in situ, while the simulation is producing data, we can perform some analysis. But in this application, we don't know what analysis we should perform, so we had to do exploratory analysis, and so we had to store all the data. So others are how to sift through all the large data, and how to display the information out of it. We used some tools that are popular in scientific world, but it may be exotic to this crowd. So one of the things I noticed here is we use HDF5 data format. This is HDF5, hierarchical data format 5. This is not HDFS, so please be advised. And we use a fast bitmap indexing technology, and we recently developed something called fast query to query the scientific data formats such as HDF5, NetCDF, and RDS-BP formats, and it uses fast bit and parallelizes it on supercomputers. And we use visit as visualization technology. And we achieved very good performance, 26 gigabytes per second on a 35 gigabits per second Lustre file system. And we used a fast bit and fast query to index the data very fast and query the highly energetic particles, what we were looking for at the time, with fast query very fast. And we used a query-driven visualization. We installed fast query within visit framework so that we only look at the data. We can just query the data and then display it as we want. So here are a couple of cartoons that you can see beautiful visualizations where we were looking for highly energetic particles. And another thing which was pretty much for the first time application scientists could see these kind of visualizations on trillion particle data. And one of the cool things we found is this was something, this is called agyrotropy, and it was for the first time they could see this, even though they were expecting it would happen. So there's our conclusions to show we achieved good performance, and the technologies we used were useful. for application scientists. Thank you.